Alright guys, let's talk about lesson 2, which is solutions and solubility. So what is a solution? A solution is a homogeneous mixture, which means there's the same molecules throughout, and it has a solute, which is the solid that's going to be dissolved, and a solvent, which is what is being dissolved into. So for example, when we look at this, we have NaCl plus H2O. The solute is the NaCl. The solvent is water, and we're making a solution of sodium chloride. Okay? So, recall. Ionic solutions are composed of dissociated ions. So when you put salt into water, what happens is those NaCl's split up, and you actually have Na pluses and Cl minuses floating around. So what does that do? That allows for us to see this picture. So what happens is water has a negative side and a positive side. The negative side of water is the oxygen, and so what the oxygens are going to do is they're going to come and float around the Na. The chlorines are negatively charged, and so the positive sides of the water, the H's, are going to come and hover around those. So remember, ionic solutions also conduct electricity and are electrolytes because you have those ions present in water. Molecular solutions are composed of complete molecules, not ions. So in this picture, we have sugar crystals dissolving into water. Solubility. The ability to dissolve is a physical property. Something that is soluble is a substance that dissolves well. Something that is insoluble is a substance that does not dissolve well and will stay as a solid. So in table F in your periodic table, we'll talk about this. We talked about this a little bit when we talked about chemical reactions, but I just want to review. So if a substance is soluble, if it's in the soluble column, it dissolves in H2O and it becomes an aqueous solution. If the substance is insoluble, it does not dissolve and will be called the precipitate. If substance is in an exception, it is the opposite. So let's look at this. Is AgNO3 soluble or insoluble? So we're going to look at NO3 because we're looking at for ions, and the ion that we're going to talk about is NO3. So NO3 is on the soluble side, so it will dissolve in water and become aqueous. So it is soluble. Let's look at this example. In this example, let's determine which of the products is the precipitate. When we look at nitrate, lithium nitrate, we have nitrate over here, so this will be aqueous, okay? And then when we make the reaction on the right, we'll have Li with PO4, okay, and FeNO3. LiPO4 is something that is soluble. Phosphates are normally insoluble except when they're combined with group 1, and lithium's part of group 1, so it's going to be aqueous. Nitrates are always soluble. There's no exception, so it's aqueous. Anytime you're doing a double replacement reaction and you have two aqueous solutions producing two more aqueous solutions, no reaction will happen. So let's look at this to determine which of the products is the precipitate. So in this case, again, we have PbNO3 plus NaBr producing PbR2 plus NaNO3. PbR2 is going to be our solid because you have Br hooking up with Pb, and it's part of the exceptions. The halides, Br is part of the soluble column, but since it's hooked up with Pb, it's going to be the opposite, which is insoluble, so it'll be a solid. And nitrates are always soluble, and there's no exceptions. So double replacement reactions. Two aqueous or ionic compounds mixed together. The reactants switch partners, and one of the products must be a precipitate in order for the reaction to take place. Table F will tell you whether the products are soluble or insoluble. So how to complete a double replacement reaction? Well, in this reaction, we have NaCl plus AgNO3 producing NaNO3 plus AgCl. So the positive ions will switch partners. So Na will now become with NO3, and Ag will now be hooked up with AgCl. Make the crisscross to make the new formulas, and then look at table F to see if any products are a form of precipitate. So let's look at this example. Complete the following double replacement reaction and determine the insoluble product. Well, the first thing you need to do is you need to split up your ions. So NaNO3 will split up into Na and NO3 minus. AlPO4 will split up into Al plus 3 and PO4 minus 3. They're going to switch partners. So we're going to get Na is going to hook up with PO4, and Al is going to hook up with NO3. Now, before we even look at this, okay, we know based off of the following that there's no reactions going to happen. PO4 is an insoluble thing, so you think it would make a solid. However, Na is part of group 1, so it will not mix, and it will become a soluble compound. AlNO3 is going to be aqueous because it's a nitrate. But since both of these are aqueous solutions, no reaction is going to happen. Let's look at this one. Okay, practice. Complete the following double replacement and determine the insoluble products. Pause the video, try this on your own, and then unpause when you're finished. Great, well, welcome back. So we split up our ions first. The positives crisscross. We make our new compounds, and then we are going to make our formulas. Now, based off on this case, Na2SO4 is going to be aqueous because sulfates are all aqueous, and AgCl is going to be a solid because anytime a halide combines with silver, it becomes a solid. So this reaction will happen. Now complete your check your understanding. Make sure you try this in your work, and we'll try it again tomorrow when you come to class.